This is next problem 4y triple dash plus 4y double dash plus y dash equal to 0. So this can be written as 4d cube y divided by dx cube plus 4d square y by dx square plus dy by dx equal to 0. Again, this is written in terms of capital D, that is 4d cube y plus 4d square y plus dy equal to 0. Since y is a common factor, we will write this as 4d cube plus 4d square plus d of y equal to 0. So the auxiliary equation for this is 4m cube plus 4m square plus m equal to 0. Since m is common factor, keep take m as common, so that will become m of 4m square plus 4m plus 1 equal to 0. Here 4m square plus 4m plus 1 can also be written as 2m plus 1 whole square. So we will get m equal to 0 and 2m plus 1 whole square equal to 0. 2m plus 1 whole square equal to 0 becomes 2m plus 1 into 2m plus 1 equal to 0. From each terms we will get m equal to minus 1 by 2 and minus 1 by 2. Finally we found three roots. There is m equal to 0, minus 1 by 2, again minus 1 by 2. Here minus 1 by 2 and minus 1 by 2 are repeated roots, real and repeated roots. Complementary function becomes c1 e power 0x plus c2 plus c3x of e power minus 1 by 2x. Next problem. d cube y by dx cube plus 6 d square y by dx square plus 11 dy by dx plus 6y equal to 0. So this is written in terms of capital D, that is d cube y plus 6 d square y plus 11 dy plus 6y equal to 0. Taking y as a common factor, that will become d cube plus 6d square plus 11d plus 6 of y equal to 0. Therefore, the auxiliary equation becomes m cube plus 6m square plus 11m plus 6 equal to 0. So, by inspection method, if we put m equal to minus 1, the auxiliary equation becomes 0. Therefore, minus 1 is a root. By using this root and also by synthetic division, we will find the other roots. So first we are going to put the coefficients of m cube, that is the coefficient of m cube is 1, coefficient of m square is 6, coefficient of m is 11 and the constant term 6, and the root that we have found by using inspection method, that is also written in left side minus 1. First put 0 below the first term, that is 1. So adding these two terms 1 and 0 will get 1. Multiply this 1 with minus 1, we will get minus 1. So put that minus 1 below the next term 6. So adding these terms 6 and minus 1, we will get 5. Now multiply 5 with minus 1, we will get minus 5. By putting minus 5 below 11 and adding, we will get 6. So again multiply 6 with minus 1, we get minus 6. So putting minus 6 below plus 6 and adding, we get 0. So neglecting 0, so first we take 6 as constant and 5 as a coefficient of m and 1 as a coefficient of m square. that will become m square plus 5m plus 6 equal to 0. So by factoring and solving this, we found m equal to minus 3 and m equal to minus 2. Therefore, we have three roots. First, by inspection method, m equal to minus 1, and by synthetic division method, we find m equal to minus 2 and minus 3. These three roots are real and distinct. Therefore, the complementary function becomes c1 e power minus 2x plus c2 e power minus 3x plus c3 e power minus x. Now, the next problem is d cube y divided by dx cube plus y equal to 0. So this is written as d cube capital D cube y plus y equal to 0. Taking y as a common factor, that will become d cube 1 d cube plus 1 of y equal to 0. Auxiliary equation is m cube plus 1 equal to 0. So taking m equal to minus 1, using inspection method, we find that m equal to minus 1 is a root. So using minus 1 and synthetic division method, we find the other roots. So here the coefficient of m cube is 1. There is no terms m square and m, therefore we put 0, 0 for m square and m, and constant term is 1. So the first root minus 1 is written left side, and below the first term 1 we put 0, and adding 1 and 0 we get 1. So 1 into minus 1 becomes minus 1. Putting below the 0 and adding with 0, we get minus 1 plus 0 is minus 1. So multiply minus 1 with again minus 1, it will become plus 1. So put 1 below the next term, that is 0. So adding those terms 0 and 1, we get plus 1. Multiply again 1 with minus 1. So 1 into minus 1 becomes minus 1. Put minus 1 below the next term, that is 1. So adding those terms 1 and minus 1, we get 0. So neglecting 0, taking 1 as a constant and minus 1 coefficient of m and 1 coefficient of m square, we get the equation m square minus m plus 1 equal to 0. So this equation, by solving this equation, we find that m equal to 1 by 2 plus or minus I root 3 by 2. Here we use the quadratic equation form. Now the roots are m equal to minus 1 and 1 by 2 plus or minus I root 3 by 2. Here minus 1 is real and distinct, and 1 by 2 plus or minus I root 3 by 2 is a complex root. Therefore the complementary function becomes c1 e power minus x plus e power x by 2. Here value of p is 1 by 2 and value of q is root 3 by 2. Therefore that becomes e power x by 2 of c2 cos root 3 by 2x plus c3 sin root 3 by 2x. Next problem, 4d power 4 minus 4d cube minus 23d square plus 12d plus 36 of y equal to 0. This is already in the form of f of d into y equal to 0. So directly we can write the auxiliary equation for this. For the auxiliary equation is 4m power 4 minus 4m cube minus 23m square plus 12m plus 36 equal to 0. So by inspection method, we find the root is m equal to 2. So by using 2 and by inspection method, so first we write the coefficient of all the terms in the auxiliary equation. Coefficient of m4 is 4, m cube is minus 4, m square is minus 23, m is 12, and 36 is a constant term. And write the first root, that is 2, left side of the table, and write 0 below the first term 4. So adding 4 and 0 we get 4, multiply 4 with 2, that will become 8. Again put 8 below the next term, that is minus 4. Adding 8 and minus 4 we get 4. Again multiply 4 with 2, we get 4 into 2, that is 8. Putting 8 below minus 23 and adding with minus 23 we get minus 15. So multiply minus 15 with again 2. Minus 15 into 2 becomes minus 30. Keep minus 30 below the next term, that is 12, and adding 12 and minus 30 we get minus 18. So minus 18 into 2, that will become minus 36. Putting minus 36 below the next term, that is 36, and adding with those terms we get 0. Neglecting 0, we take minus 18 as a constant term, minus 15 as a coefficient of m, 4 as a coefficient of m square, and 4 as a coefficient of m cube. The equation becomes 4m cube plus 4m square minus 15m minus 18 equal to 0. So again this is a cubic equation. We have to solve this again to make as a quadratic equation. So again taking m equal to 2 and using inspection method, we find that m equal to 2 is a root. So using 2 and the coefficients of the above equation, using synthetic division, first write the coefficient of m cube, that is 4. Next coefficient of m square is also 4. Coefficient of m is minus 15 and the constant term, that is minus 18. So taking the root 2 in left side and putting 0 below the first term 4, and adding with 4 we get 4 plus 0 is 4. Multiply 4 with 2 we get 8. Put below the next term, that is 4. So adding those terms we get 12. 12 into 2 becomes 24. Put 24 below the next term minus 15, and adding with minus 15 we get 9. So 9 into 2 becomes 18. So put 18 below the next term minus 18, and adding those terms we get 0. So now neglecting 0, taking 9 as a constant term and 12 as a coefficient of m and 4 as a coefficient of m square, the equation becomes 4m square plus 12m plus 9 equal to 0. So this can be written as 2m plus 3 whole square equal to 0. That will become 2m plus 3 equal to 0 and 2m plus 3 equal to 0. So finally we get m equal to minus 3 by 2 and minus 3 by 2. So we found that the roots of m are, the roots of the given equation are 2, 2, minus 3 by 2 and minus 3 by 2. Here 2 and 2 are real and repeated, and also minus 3 by 2 and minus 3 by 2 are real and repeated. For these roots we have a complementary function y is equal to c1 plus c2x of e power 2x plus c3 plus c4x of e power minus 3 by 2x.